So welcome for today's lesson. So today's lesson we use chemistry as study help for test two preparation. And when you look at there, this will be our content. Yes, indeed, chemistry is simple. So try to look at the definition of acid. Those who develop acids. So try to look them to consider them. Even the molar solvent KSP and buffer solution pH and pOH. That's what we'll look for today's lesson. Yes, let's proceed. So, you need to know on acid bases equilibrium. First thing we need to know the definition of acid. So, what are the definition of acid? Each theory developed the definition of acid. There, there were scientists who developed theory of acid. The first one which you need to know it is Arrhenius theory. So Arrhenius theory it says or it states that an acid it is anything which increases what? Anything which combine or which dissolve in water to increase the positive ions. So if anything or a solution, this is a solution, combine with H2O, like this is the H2O. Now this solution, okay, so this N solution like H, yes, so N solution which combine with H2O to give us or to increase hydrogen ions. That is what we are calling acid. Or acid, they just increase the concentration of hydrogen ion or hydronium ions. So I have an example of this, which is in our question of HCl there. So when HCl there, dissolve, it form as what? It increase H positive. Yes, H positive plus yes chlorine which is there. So it is increasing the hydrogen ions have been increasing. That is what the definition of Arrhenius developed. It developed that an acid is anything or any substances which increases hydrogen ion or which when it dissolve in water produce hydronium ions. That's what this Arrhenius theory state. What about Arrhenius bases? So Arrhenius bases is a substance that increases the concentration of OH. So what you need to know acid. So what you need to know. Acid increases what? Hydrogen positive, while a base what increases what? OH. That's the only thing which you need to know according to the definitions of Arrhenius equation and some examples. Try to know these examples for acid and also for bases. This document, if you don't have this document, you can inbox me on the number 0973 17 81 00. So you can inbox me on this number so that I share this document. It's very important and it will help you as you prepare for test 2. That's the only thing which you need to know on Arrhenius theory. Now let's proceed. So those are the Arrhenius theory. Now you need to know also the definition of acid using the concept of Bronston Lary. So Bronston Lary is also a scientist who developed an acid. He developed that an acid, or he found that an acid, it's the substance which donates a proton, or we can say this is a proton what? Proton donor. Yes. So proton donor, that is what we are calling an acid. That is a proton donor. A base is a proton acceptor. Yes. So according to Bronston Lady, he said an acid is a proton what? Proton donor. Yes. So proton donor. According to Bronston, according to Bronston Lady theory, and we are saying that a base is what? A proton what? So a proton acceptor. So you need to know this acceptor. And also some examples. Let's go to the examples we see. So some examples of these are HCl. So HCl there, that's an example of Bronston acid. Yes. So you need to know also the examples here. So get familiar with these examples and also the examples of bases, because they will ask you, yes, identify this. Is this the Lewis acid, Bronston acid, or Bronston Lady bases? So you need to know this. Yes, try to know them. So it is important. Yes, and we go to another theory which you need to know, Lewis theory. So Lewis theory there is stated that an acid is what? An acid. What does Lewis theory state? An acid, it's a substance which accepts the pair of electrons. So acid accepts the pairs of electrons. So an acid accepts the pairs of electrons. While the base, what is the base? So the base there, the base also, so an acid accepts the pairs of electrons, while the base there, it accepts, or it's, I can say, it donates electron. It donates the pair of electrons. That is a base. According to Lewis' definition of a base, it is electron donor. Yes, so electron donor. So it's electron donor. So you need to know this concept. It's very important. An acid, according to Lewis theory, it accepts the pair of electrons, while the base, according to Lewis theory, a base, it is the electron donor. So it is the opposite with Bronston Lewis. Bronston Lewis said proton donor, while here Lewis theory stated electron donor. Have you understand this? Electron donor and proton donor. So here it says Bronston Lewis, he said it's a proton donor. While here it says deals with an electron. Lewis theory deals with an electron acceptor. So an acid, according to Bronston Lewis theory, it's a proton what? Proton donor. Wow, when you come to Lewis theory, an acid is an electron acceptor, which accepts the electron. Wow, the base to proton theory, the base is what? So the base, it is the proton acceptor. Wow, when you go to Lewis theory, an acid is what? An acid, or a base is the electron donor. So that is the only thing which you need to know. You need to know the definitions. Yes. What other thing which we need to know? That's the only thing. Let's move on. So another thing which you need to know, how question they will ask you, what sort of question they will ask you. So example, exam style questions. I have these exam style questions. They will ask you, identify Lewis acid and base. So you need to know all those examples. Yes. So which of the following are Lewis? Which of the following are Lewis, and which are Lewis bases? So here I've explained there. So you can use this document as a difference. So Lewis acid does what? Electron pair of electrons. So when you look at there, B fluoride. I'll explain this. So here according to this, fluorine, fluorine. So you combine with fluorine there like this. And when you look at bromine there, or boron, so you combine with fluorine like this. So this is so when you look at this, so the question is, which of the following are Lewis acid and where are Lewis bases? So like the example there, electron pair acceptor. So this boron acts as electron pair acceptor. So it has accepted electron from fluorine and fluorine, so it's to become in its octet state. That is why this boron qualified to be Lewis acid. Yes. So I said you need to know all those examples. Yes, even Lewis there, H2S4, Lewis base, ion pair on sulfates. Yes, and also Lewis acid, Al, aluminium chloride. So Lewis acid electron defeats Al, and Lewis base can donate a lone pair. So this is the one thing which we need to know. They will ask you questions like this. So my encouragement there is what you need to know the examples and the concept. They can tell you to explain Lewis acid, Lewis base, Bronson ready acid, yes, even Arrhenius acid and bases. So you need to know this. They will usually ask you, yes. So they will ask you questions like, but there is also another key which I need you to know this. There is a key there. This true and false. This is important because they can relate the relationship between Arrhenius bases. They can relate one theory to another. So the thing which you need to know, all Arrhenius bases are also Bronston-Ley bases. So all the bases of Arrhenius, the first theory which we considered today was Arrhenius. So all Arrhenius are also Bronston-Ley bases. So you need to know this. And all Bronston-Ley acid are Lewis acid. So try to know this. This is the key. They will relate this question. What is the relationship between Arrhenius theory and Bronston-Ley theory? So you can say this relationship is based on bases. All Arrhenius bases are also Bronston-Ley bases, but not vice versa. Bronston-Ley bases cannot be Arrhenius. All Bronston-Ley bases cannot be or Arrhenius bases, but some. So there they say all Arrhenius bases. Why? Because Arrhenius bases, they are what we call proton acceptor. So it qualifies to be in Bronston-Ley bases, which donates electrons, which donate electron pairs. So they are, yes, so they are qualified to be Bronston-Ley bases. And also all Bronston-Ley acid are Lewis acid. Yes. So you need to know this. All Bronston-Lewis acid are Lewis acid. So you need to know all these relationship. Yes. Now we go to another important thing which you need to know. They will ask you, what is a conjugate acid and a base? So I'll give an example, which is HCl. HCl, like this. So HCl there. Okay, let me use which you have already used, so that it can be easy for you to relate, even if you are passing through this document. So when you look at there is this is an acetic acid, which is CH3COOH plus ammonium, which is a base, so giving us this conjugate and an acid. So how can you identify a conjugate? So when you look at this reaction, so the opposite of this an acid, according to the definition of remember the definition of Arrhenius, it says that an acid which It's a proton. Okay, according to the definition. So according to the definition, according to Bronston Rory, an acid is the an acid. It is the proton what? So it's a proton accept proton don, that is an acid. And also Arrhenius said that an acid is a substance which increases what? Hydronium ion, or which increases what? Hydrogen. Yes. So when you look at there, this acid plus ammonia. So what will happen? Hydrogen there will be lost. There will be lost. So if they have asked you to write this equation, any equation which deals with an acid, you need to know that hydrogen will be lost. Any equation, if you don't know the equation, they say write the equation for this. They have given you this is an acid, you don't know. So example, which equation can I give you so that you can relate? So example, I'll give you like, but I can give you an example which is so that you can easy to relate. HCl, they give you at HCl plus H2O. They give you this. Now they say hydrochloric acid dissolved in water. What is the equation? I don't know the equation. I know this is an acid. What should I do? What should I do? So the only thing which you need to know that an acid there will lose what? Hydrogen. The first thing which you need to know, hydrogen will be lost. So what will be our equation? So B. So the final, if HCl dissolved in water there, so what will be our equation? So you need to know what is the dissociation of this equation. So you need to know that hydrogen there will be lost, so it will be HC what? HCl negative. So because hydrogen there from E will be lost there, so it will be Cl negative there, and there where only H2O will gain what? Will gain hydrogen. So that's why it will be H2O. So this will gain hydrogen, so it will be H3O positive. So this is the key. When you don't know, so when they have given you equation, you need to, if they have given you a question to make an equation, if you know that this is my acid, and this is, so you need to know the concept that acid, they will do what? They will lose hydrogen. And if they have given you, if it is a base, which is ammonia, I'll give an example of ammonia dissolved in water. What will be the equation? I don't know this. I know this is the base. So a base gains what? Gains hydrogen. So a base do what? Gains hydrogen. So what will be the final? So if it's my base dissolved in water, okay, let me write on top. So I have this ammonia. So if this is a base, so it dissolves in water, H2O. What will happen to this ammonia? So this is the base. So the base will gain what? Will gain hydrogen from there. So the formula will be NH. So gain hydrogen, so will be 4. Yes. Then so will be positive there plus OH, because there you lose one hydrogen, so remain with the 1H. But an acid, we said on an acid is the opposite, HCl. On an acid, when dissolved in water, so even if you don't know, you need to know this concept. Even if you don't know how to create or how to make the equation, you just need to know this concept. It is helpful. So if this is an acid, I know this is an acid. An acid will lose what? Will lose hydrogen. A base will gain what? Hydrogen. So you have, so chlorine there will become negative plus H3 what? H3O. So this will help you. This concept will help you to develop or to make what? An equation without difficulties. Now, how can you identify this is a conjugate base, a conjugate acid? Now, if this is an acid, let me use another card. So if this is an acid there, If this is an acid, this is chlorine. So now, if this is an acid, this is the chlorine. So if this acid, this is an acid, so the conjugate for this, it's a base. Wow, here will be an acid. Yes, oh, yes. So if this is an acid, then it will be base, then the hydrogen will be an acid. Yes. So if this is, it will be a base, so it will be opposite. So if this is will be the base, so H2O will gain hydrogen there, which will be H3, and that it was a base, now it has become acid. So this is what we are calling conjugate base and conjugate acid. Yes. So it's the opposite. If this is an acid, then this will be what? A base. If this is the base, this will be an acid. So similar to E, this is ammonia. It is what? A base. So if this is the base, what is the conjugate of this? So the conjugate of this is this. So since this is the base, then this will be what? An acid. Then this is H2O. This is what? A base acting as an acid now. Water can act as a base or an acid. Yes. So water can act as a base or an acid. That's why we're using H2O. Here it's acting as an acid. Here it's acting as an acid. So here the OH there, it will become as our base. So this is the only thing which you need to know, conjugate. So here this side you are calling conjugate, and this side you are calling conjugate. So this is the only thing which you need to know on conjugate. Identify the conjugate base, identify the conjugate acid. Yes. Yes, another important thing which you need to know, even the definition, dissociation and ionize. So they will ask you, what is the difference between ionization and dissociation? So ionization, you say dissociation deal with strong acids. So this is the strong acid, while ionization deals with a weak acid. Yes, that's the one thing which we need to know. And also I have this here. What you need to know, they will give you identify if this will be a weak acid or a strong acid, relation to their Km, equilibrium constant Km. So there it says the weaker the acid, the smaller the Km. The stronger the conjugate base, but you looking for the weakest base without the conjugate of the strongest acid. So you understand this as you try to see the question. If we are saying, if you have given you the Km, so the bigger the Ka, the stronger what the acid. Wow, the conjugate base will be weak. So let's give an example. We have this question. This question there says, which of the following conjugate base? Question 4. We're going to question 4. So question, which of the following conjugate base is the weakest base? So we have the Ka there. We have 5.6 times 10 to the power negative 10, and the K 1 point times 10 to the power negative 4, K 1.6. So we explain that the stronger the acid, the Ka should be what? Greater. Now the question they ask us, which of the following conjugate base is the weakest base? So conjugate base is the weakest base. So conjugate base. So we know that the conjugate base there, weakest base. So the Ka should be what? The K should be bigger. So when the K is bigger, and also an acid will the acid will also be the acid should be strong. So the K is direct proportion to the acid, while inversely proportion to what? To the base. So the base will be weaker. So the answer there, we just pick where the Ka is large, so which is HNO2. So when you look at there, 5.5 times 10, so the Ka there it's bigger, so it will be the weak conjugate base. So that the answer is this one. That is the only thing which we need to know. Let's proceed. Okay, so this is also try to answer those questions. Okay, so I like this also encouragement. So even if you are facing a lot of pressure, at least smile. That is the key to success. Yes, you need to smile. This is the key to success. Yes, even if you are in a lot of pressure, the key there you just need to smile. Yes, and it truly helps. Yes, let's proceed now. What you need to know, you need to know what is pH. So pH there, it is measured in acidic. So pH is measured in acidic. pOH measured basicity, or how alkaline the substance is. Yeah, so basic is measured by pOH, and the formula is so pH. The formula for pH, you need to know the pH is equal to negative log. So negative log of H positive. That's the only thing which you need to know. Now the pOH is the same, but we say negative log what? Negative log OH negative. Yes, so that is the only thing which you need to know. Even so Ka, so constant at equilibrium. Ka deals with at equilibrium. Kb, it is a, you need to know Ka times Kb is equal to what? Kw. So Kw, which is 1 times 10 to the power negative 14. That's the only thing which you need to know. And also, question they will ask you to determine Ka, Kb, even pH, pOH. Yes, let's try to answer some questions which they will ask you. So I have these questions. So sometimes there is when we cancel x in the I'll explain where we cancel x. So write the K or Kb expression for acidity. So Kx squared, which is x minus b. Then if Ka a over Km is greater than 100, you can cancel x. I'll explain that. Let's try to answer some practical questions. So question 1, I have this. Now, yes, question 1 is 0.11 more solution of NH3 is put in water. Kb is 1.8 times 10 to the power negative 5. Now we know that the question light ionization reaction. So you need to know, I have explained how you can light here, which is NH3 has been put in what? In water, which is H2O. So what will happen there? So if this is the base, so ammonia is the base, so it will increase, H will increase with so it will increase with hydrogen, so it will be H4, which is will be positive, then plus what? Since you here it will lose one hydrogen to be 1, so it will be OH negative. So it's the only thing which we need to know. Yes, and they ask us, so if you know this, how you can write this equation, then they ask us find pH. So you need to know, we need to write the ice table. So the ice table has initial, the change, and the equilibrium. So initial like this, that's the ice table. Now here, when you look at the question there, so you have developed this equation, NH3. So NH3 there start with how many? any 3 start with the concentration is 0 point, so you write 0 0.011 more. And there for the product, since we don't know the product, here the product, so here, because on ice table there it deals with aqueous, not solid or liquid, but aqueous and gas. So ammonia there and this. So there we don't know, we didn't start with anything, so it will be 0, even here 0. So the change there to be x, there will be x, there will be x. So much we will subtract, which is 0.011 minus x. That will be at the equilibrium. Yes. So x there. So here will be our x, and here will be our x. Now here will be, the last table will be 0.018. Now what will be the K expression? So the K expression will be, since this x, so it will be x squared over 0.011 minus x. That's the K expression. Now we want to find x. So x, what should we do? So since there we know how we can calculate. How can we cancel ex? So we can cancel x. What is the situation we should cancel for x? So the situation which you need to cancel x, you need to know this. You need to test if 0.011, that's the concentration, we will divide with the Ka. So when we divide the Kb, which is 1.8 times 10 to the power -5. So when we divide there, is it giving you more? So it's giving you more than what? When you divide, giving you more than what? 100%. So when it give you more than 100%, then there below you need to cancel. So x squared. So here below there we will need to cancel negative x. So cancel. Here we add 0.00111. So we need to cancel x there. So that is our Ka expression. So now, so our x is equal to, so for the same thing, so this will multiply with Ka. So 0.1 times Ka. Yes, x here will be squared. Yes. So our x, when you multiply this times K, it will give you what? 4.45 more. So this is the hydrogen ion. This is the hydroxide ion. So like that. Then you find the pOH. When you find the pOH using negative log OH, then you also find the pH. So pH plus pOH. So pH plus pOH is equal to 14. Then you find also the pH, which will be 14 minus pOH. So that's the only thing which you need to know. Yes, that's the only thing which you need to know. So the document has explained in detail all those concepts without difficulties. Yeah. So there they say, use this document to change you like a base turn into its conjugate acid. You'll be happy and confident while writing your chemistry test too. So try to use it. It also has explained the buffer solutions. So on the buffer solution, you just need to know what you are calling what Hensberg equation. So Hensberg equation there, which will be used to apply to answer here. So just need to know Hensberg equation. Yes, and also how you can apply Hensberg equation. So the pK is equal to negative log of Km. Then you apply in the Hensberg equation. So you need to know the Hensberg equation. Yes, even you try to pass through the document, as explained this in detail. Yes, And molar solubility has also explained the number of moles solute that can dissolve per liter solution. So even the molar solubility, the KSP, yes. So you need to know it. Yes. So for more explanation, please buy chemistry exam study app. So even an exam study app will be released. So today's lesson we end here. So if you want that document, you can inbox on the number 0973 17 8100. It has explained more in detail.